Greetings and welcome, friends! Math fans and circle fans have all come together for the perfect video on the internet about segment relationships in circles. The perfect video, yeah. And I haven't even finished this video yet, and I've got a feeling it's the perfect one. If you imagine the ideal YouTube video, it's this one, actually. Google did a massive data search through their servers, and this was the average of all videos combined. It's the ideal. But I've got predictive technology that I was able to determine this. So let's see. Using segments of chords, tangents, and secants. When two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of the chord. All right, so these two segments, chords A, B, and C, D, are broken up into A, E, E, B, and C, E, E, D, right? And it says, the segments of chords theorem. If two chords intersect at the intersection of a circle, then the product of the lengths of the segments of one chord, all right, so that's going to be AE times EB, is going to equal the product of the lengths of the segments of the other chord. So CE times ED, right? So that's the idea. That's the idea. Not necessarily an obvious thing. And I find this interesting, right? Using geometry, we're able to discover these things. And then they're true, and they're true forever and all time. It's great. Good stuff. Good stuff. So, oh dear. Wow, they just jumped right in with this, didn't they? So, I've got two chords that intersect at point N. Therefore, the product of the segments of chords, x and x plus 4, is going to equal x plus 1 times x plus 2. I distribute that over here. I'm going to have x squared plus 4x equals, and let's FOIL this over here. X times x is x squared. X times 2x is, x times 2 is 2x. And 1 times x is plus x, and 1 times 2 is plus 2. So, we've got to combine like terms. So, x squared plus 4x is equal to x squared plus, looks like 3x over here, plus 2. And fortunately for our sakes, this is no longer quadratic. When I subtract the x squareds from both sides, cancel out. I can also subtract 3x simultaneously, if you like to live dangerously. 4x minus 3x is x equals 2. Bam. I like it. All right, so that one's not that bad. Let's talk some more vocabulary. Vocabulario. Here we go. Bop. All right, core concept. A tangent segment is a segment that is tangent to a circle at an endpoint. All right, so here's a tangent segment, like so. So one of its endpoints is also the point of tangency. A secant segment is a segment that contains a chord that has exactly one endpoint outside the circle, like so. Let's see. All right, so the secant segment is the entire thing. Here it goes. And then the part of the secant segment that is outside the circle is called the external segment. So PQ is external. The entire secant segment is listed as such. All right, lots of vocabulary, but vocabulary allows us to communicate specifically, and then we can describe relationships between these specific things that we are describing, such as the following theorem. Yeah, I told you this was going to be the perfect video, guys. Told you. All right, here we go. Segments of secants theorem. If two secant segments share the same endpoint, right, outside a circle, then the products of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. Now, when it says secant segment here, all right, secant segment, that's referring to the entire piece. All right, there's one, and the other secant segment is referring to the entire piece. So it's the external part multiplied by the entire, and the external part multiplied by the entire, and those two products are going to be equal to each other. All right. My tendency would have been to say, oh, EA times AB, but no, don't do that. Do not do that. All right, so let's look at example dose. Ba-da-ba-ba. Where did it go? There it goes. Let's see, we'll scale this down a little tad. We'll dilate that. All right, don't get fooled by this now. So, according to this, okay, hey, look at these. These two secant segments intersect outside of a circle. So therefore, 9, the external piece, multiplied by not 11, but multiplied by 20, okay, is going to equal 10, the external piece, multiplied by x plus 10, right? So guys, don't get fooled by this. In this case, the simple outcome is not the correct outcome. So let's see, 9 times 20 is 180. Distribute that, that's 10x plus hundo. Subtract hundo from both sides. I'll get 10x equals 80. Divide both sides by 10, x equals 8. Right, the algebra we're good at. It's just going to be a matter of, can we do the, the original setup. Here, let's see. This problem's interesting. This is monitoring progress question 4. I skipped 3. Let's just set up the equation here anyway. So I'm going to have 3 times what? So the external multiplied by what? Anybody? Yeah, I've got to add those together, and that's going to equal the x plus 1 external multiplied by, and this one actually would need parentheses around it as well, x plus 1 plus x minus 1. Okay? So I need to work with the entire lengths here. Right, that's the tough part. Right, making sure that you're working with those entire secant segments. All right. You would then combine all like terms and then distribute. Over here, you'd end up having to FOIL. You'd have a quadratic that would show up for just a little bit. By the way, if you end up doing this problem out, your solutions are x equals -5/2 and x equals 3. But we will not continue to do that problem. All right. The secant, the tangent is a circle theorem. It's called the segments of secants and tangents theorem. All right. Which, okay, this makes sense. All right. EA times EA is going to equal EC times the entire length across. Okay? So that's that part there. So notice, in this case, you could view EA as being the external segment of a secant, and EA is also the entire secant segment, but oh, the secant segment happens to have a 0 length for its internal part. Right, and EA times EA is EA squared. It's in the game, from what I understand. What I heard. Don't know about you. Don't know about you. All right, so let's put this to use real quick. Let's see. Aiden SD, you help me set up this equation. What are your thoughts? Yeah, seems to make sense to me. You would distribute and you'd combine them. If you had a squared term, actually, whoa, we're going to have a squared term here. This is going to be great. Let's distribute. You'd end up setting it equal to 0 and solving by either factoring, completing the square, or quadratic formula for if it's quadratic. Let's see. X times x is x squared. X times 8 is 8x equals 16 squared. What's that? 256. Subtract 256 from both sides. X squared plus 8x minus 256 equals 0. So I set this equal to 0. And now, oh, your book actually decided to solve. Oh, it's not factorable? Yeah. You would factor it, set both factors equal to 0, and then solve. All right, so the answer is not the factors. The answer is what the value of the variable is that makes those factors equal to 0. But you guys, in this case, the book is recommending using the quadratic formula. Have you guys ever seen the quadratic formula? All right, here we go. Let's sing it for our internet friends. Once again, making this the perfect video on YouTube. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Hooray! So we would end up plugging in a equals 1, b equals 8, gentlemen, c equals negative 256. I would plug all of those in for locations a, b, or c and solve, and tell you what, internet friends, I don't know. The geometry is. I don't know if a quadratic formula problem is. I'll have to go check. But either way, you'd plug in A, B, and C and simplify, and you get two solutions algebraically. But the minus one, the negative one, doesn't make sense for a distance, so we only consider the positive solution, and you get about 12.49 is that length. All right, let's do, what about a circular, looks like a shark tank or something here. Oh, you're writing that down? All right. Which, by the way, if you need help with quadratic formula, you can go to Wadi Math and just search quadratic formula, and you will find some videos of me, probably like 3 or 4 years old. It'll help you out. So I'm going to alley-oop this to past Wadi. Oh, I wish. That would be amazing. I need to get Everett, my oldest son, to start his own YouTube math channel right now. He's already 5. It's too late. He's past his prime of teaching math as a 4-year-old. That's too bad. I could have given him like that Wadi Math boost as well, of like, you know, sending some people his way to subscribe. Actually, today is a great day. I've got 144 subscribers, which is a perfect square. Not the biggest number. The number that I have more of is not subscribers, but my views, which I've got 68,000 views right now. So no, I don't think my content is as entertaining. Yeah. Unless I like retitle this video like 3 ways to find the lengths of segments in a circle that so-and-so hates or whatever, and then people will be like, wow, I so want to know this. Yeah, oh, there you go. All right. Harambe's favorite ways of finding the lengths of secant segments. Right? There you go. All right, so imagine Harambe lived in an aquarium. With sharks. I don't know. Actually, I have heard questions before of like who could win in a fight, a great white shark or a T-Rex. It depends. What are your thoughts? I can help you out. Yeah. You can eat whatever food you find in there, but if it's poisonous to you, I'm sorry. There is peanut butter in there. Don't die. Go for it. Well, some would ask, like maybe if it's in like 3 foot deep water. But I think, and then like the best answer I heard was that a great white shark would win in a single bite when dropped from 10,000 feet. Right? Yeah, probably. So it would be a tie. But that's how you could do it. But these are the questions that virtual reality and artificial intelligence will answer for us in this generation. So let's see. Find the radius of the aquarium tank. Okay. So I'm going to say that 8 times 8 plus 2r is going to equal 20 squared. You guys feeling that? And so 64 plus 16r is equal to 400. So 16r is going to equal, what's that, 336? Did I do that right? And 336 divided by 16. R is equal to 21. Right, but once again, the key was realizing I needed this entire length across. All right. Well, let's call that a video, and I'll call it. I should title this something about great white shark. I solved for R, so the radius is 21. Yep. Great white shark versus T-Rex. Bye-bye.